Here are solutions to perfect problem 4 for Math 111. Function transformation is what we're doing here. So kind of worded in a difficult way. I don't even give you a function. We don't even have the graph of a function or the function itself. I just tell you one point on that function. I tell you that, so this is for part 1. I tell you that 2, 3 is on f. So I give you 1 point, only 1 point. Maybe we'll even graph that 1 point. Let's see, 1, 2, 1, 2, 3. Here's a point. It's on f. And what I want to figure out is 1 point, maybe where this point ends up on this other graph. Maybe I'll switch colors, calling it G, and defining it in terms of f as -2 times f of x minus 5 plus 3. So kind of what you have to do is figure out what transformations are going on here. We have either 3 or 4, depending on how you want to think about it. There's 2 vertical transformations. And it's kind of important what order you do them in. One has to do with this 2 or this -2. And the other is with this +3 right here. This -2, maybe stretch horizontally by a factor of -2. Maybe even parenthetically, or stretch by 2. Then flip. You'd be flipping over the x-axis. I prefer to think about it just as one thing, but if you want to think about it as 2 separate steps, that's fine too. Then the next thing you do is you shift up 3. So this +3 causes you to shift up 3. This -2 causes you to stretch horizontally. That's not true. Stretch vertically by a factor of -2. And then once you get those, there's one more transformation. We haven't talked about this -5. That's actually a horizontal transformation. It's the only one. We'll list it down here. -5, you might think that means that it should go to the left by 5, but it doesn't. It actually goes to the right by 5. It'd be shift right 5. So back to our graph here. See, maybe we'll take care of the vertical transformations first. It doesn't really matter which ones you do first, whether you do the vertical or the horizontal. I want to stretch vertically by a factor of -2. So this point right here used to have a height of +3. So if I multiply 3 by -2, 2, 3, 4, 5, 6, 3 times -2 is -6. That'll move it all the way down here. Maybe I'll label these points. This one is 2, 3. This one is 2, -6. That's just taking care of my first transformation. So kind of first step is to go from here down to there. My second step is to shift up 3. So I used to have a height of -6. If I add 3 to that, I get to -3. So that would bring me somewhere right in here. So next I kind of go up here, and I get to this point at 2, -3. And I'm almost done. I just got to horizontally shift. I'm going to go to the right by 5. So now what I'm doing is I'm changing the x-coordinate. It used to have an x-coordinate of 2. But if I add 5 to that x-coordinate, I get up to 7. So 1, 2, 3, 4, 5, 6, 7. Bring me somewhere over here. Jump over to here, to 2. Nope, that's not true. To 7, -3, which is my final answer. So let's see. Part 1 asked me, what point must g of x equals this thing go through? The answer would be, here we go. How about up here? 2, 3 is on f, so 7, -3 is on G. That's my answer for part 1. Probably smarter ways to write that up than I did, but hopefully that's enough where you can see the answer. We'll move on for 2. So for part 2, it says g of 4 equals negative 9. So what that tells me is that 4, negative 9 is on G. So what I want to do is figure out f of negative 1. I want to figure out the y-coordinate when x equals negative 1. Well, what I can do is I can kind of undo everything. Instead of going in this order like I did above, I can kind of go backwards. The last thing I did here is I shifted to the right by 5. So if I kind of undo my shift right by 5, then that takes 4, negative 9 to negative 1, negative 9. Because to undo shifting right 5, you'd shift to the left by 5. If I shift to the left by 5, my x-coordinate would change from 4 to negative 1, but the y would stay the same. And then what I'm going to do, that takes me here. Now I want to undo my shift up by 3. So to undo shifting up by 3, I want to shift down by 3. That's not going to affect the x-coordinate, but the y-coordinate, which used to be at negative 9, is now going to be at negative 12. And then finally, I want to undo my stretch vertically by a factor of negative 2. And so you kind of think about what must your y-coordinate have been so that when you multiply it by negative 2, you get to negative 12. Well, the answer to that is 6. So what I'm saying is the point negative 1, 6 is on F. If the point negative 1, 6 is on F, that means f of negative 1 equals 6. So the question was asking, what's f of negative 1? 6. 6 is the answer. I guess that's good. That's the end of this problem.